My name is Chris Davis. You're in the open source wrapping, the gift that keeps on giving discussion. 3:15 on Thursday afternoon. Everybody's ready to go home from NI week. I hope you've had a good one. I know I have. I got an excellent opportunity to be on the keynote stage the first day, and so that was really a treat and something to remember for a while. I'm going to talk a little bit about open source and how my company and how the group that I work in uses open source libraries and wraps them and pulls them into LabVIEW and some of the things that go along with that. This week I've also been talking a lot about security, cybersecurity specifically, and how my company and how I see the cybersecurity world and how that interacts. And open source has definitely been a part of that. So that's going to flavor our discussion as well. Since we don't have a ton of people here, if you have a question, please reach out. There's a microphone right there. I think the session's being recorded especially for GDevCon and for published to YouTube. So if you've got friends that you think might enjoy this later, or colleagues that might enjoy this later, please feel free to reach out and send it on to them. I'll also be giving this presentation, or at least a version of this presentation, at the GDevCon NA that's occurring later this summer. I think it's towards the end of July in Chicago. So I'll take these slides and probably modify them a little bit and talk a little more technical content as we get a little deeper in that as well. So, picture of me from 2015, right? Yay, last time I had professional pictures done. I was a little younger then. But again, my name's Chris Davis. I'm a senior engineer at Amentum, senior software engineer. It's my email address if you want to get in touch with me. I've also got business cards up here. I did mention GDevCon, and so wanted to put this up for just a few minutes. They've asked us as technical presentations that are being sponsored by GDevCon. To kind of put this slide up, the QR code, I think, helps you get information about your regional event if it's close to you. But you can see there's one in Asia, North America, Europe, Australia, and then Latin America. And then they had one in Asia just in the last couple of months as well. So there's one close to you, right? This is an excellent opportunity. I've been to several GDevCon North Americas now. I think this may be my fourth one coming up this year. It's an excellent opportunity. It is really that kind of LabVIEW user group. I like to think of it as a LabVIEW user group that's really just an advanced, medium to advanced LabVIEW user group where there's topics over the 2 or 3 days they cover the breadth. Some of it is beginner stuff, and some of it is that much more intermediate and advanced stuff that you just don't get a lot of in LabVIEW user groups. Or if you do, you get it maybe once a month, right? It's like going to a LabVIEW user group for a whole week where you're getting really good technical content. So if you've got questions about any of these, or again, the QR code is an excellent way to get information for one that's in your area. Okay. So we're going to talk a little bit today, again, kind of go through some concepts and definitions just to get everybody on the same page, some history of the particular project I'm talking about, and then go through kind of our goals as we looked at this project and how we wanted to replace it, what were our goals when we went through that process. We'll talk about the library that we used, and then kind of our process as we took through that, and then we'll talk a little bit about the things that we learned. I do have a question slide at the end, but again, if you have questions, raise your hand or speak up, come up to the microphone. We'll take them as I go. I'm pretty casual presenter, so happy to answer questions as we go through stuff. All right, so a couple of concepts and definitions I wanted to touch on. The concept of open source, I don't think it's a new concept for software developers, especially at this conference. I think it's something you've heard about, but just in case you haven't, like the idea of having source code that you have full access to, that's usually provided without a warranty because it's not necessarily a company standing behind it, but it's a set of source code that individuals has developed over time that you have full access to the source code to. It usually has some sort of license associated with it. But it is available and open and free to use oftentimes. A lot of open source there's LabVIEW open source that's available to use and typically distributed through VI Package Manager. But then some of the things we're going to be talking about today are open source in other languages like C and C++ and C#, Python libraries, things like that. Typically, when we interact with those types of libraries and those other languages, we do so through a shared library and using the LabVIEW call library function node. That was one of the gentlemen that asked about the code interface node, which I think was just deprecated. But the call library function node is how we typically will integrate DLLs and shared objects within LabVIEW. And then we're going to talk about the concept, we'll bring up the concept of unit testing within today's presentation. We're going to talk about a particular open source projects and family of open source projects really in Redis, right? So Redis is an open source tool. The Redis stands for Remote Dictionary Server. It's an open source tool that's an in-memory data structure and a data store. It's used primarily as like a key value database lookup and database cache. A lot of web tech, it's used a lot in web serving and web technologies where you're hitting maybe a large database, a web page hits a large database, and that database doesn't change very often. It may change occasionally, but doesn't change very often. So when users hit that database, rather than each one of those users causing a query to execute on that database, you could do some sort of cache of the information that comes back from a query that occurs very often, and ideally that would get replaced or refreshed at some point in the future. So Redis has this idea of that maybe the first time somebody hits a query, we get that information and we cache it in an in-memory data store. That's Redis and that data dictionary, so that when we get that query again in the future, it's very, very quick to return that information. But Redis is not a permanent data storage, right? It isn't in-memory database storage. It has very little disk space gets used. So it's really that caching level or that caching layer is how it's typically used between, let's say, a web page and a database hit. It is one of those open source projects that has a lot of different tendrils and a lot of different capabilities. One of its capabilities beyond serving as kind of a database cache is also a message broker. So it has kind of a pub sub subscribe capability. It has data streaming. It has like in-memory JSON editing that it can do a lot of different capabilities. The reason that we started looking at this long ago is the application that this kind of started became a replacement. Redis became a replacement for was using network shared variables, which again is a technology that's been around that LabVIEW and National Instruments has supported for a long time. But if you've ever used those, you recognize they have some limitations, and certainly they're well supported within the LabVIEW ecosystem, but not so well supported outside that. So if your LabVIEW ecosystem or your LabVIEW application has to share data with outside programming languages such as Python or C#, network shared variables can be a kind of a strange way or a difficult way to integrate into other languages. And so as we started looking for replacements for those network shared variables, we happened upon Redis and started to see what it was used for and see how we could use it. And so at least for some of the things we're talking about today, some of the ways that we have used it, again, not the only way it can be used, some of the ways that we have used it, you can think of it as we have used it as a replacement for network shared variables. And then again, a definition, DLL or a shared object. DLL is the Windows-specific term for it. Shared object is typically used on Linux and on Mac OS. But it's the type of file that lives on the operating system that's a compiled binary file that is kind of a shared library and serves as a way to share compiled executable code that is not user-facing. Typically, it's some sort of data or resources used by multiple applications to improve efficiency. It helps DLLs and shared objects tend to prevent you from having to embed all of the code into a single executable, and so it makes your code more modular. It makes it easier to distribute. It makes it easier to replace those libraries over time as new versions come around, either for cybersecurity reasons or for capability reasons. Those are where DLLs and shared objects are usually used. Nope, sorry, that was the laser. There we go. All right, so the project that the toolkit I'm going to talk about, it was kind of an internal tool that my name of the main name of my company comes into play here, right? So our current name is Amentum. We were once the company Jacobs, right? So that's why this is called the Jacobs Redis Toolkit. But this was a toolkit that I created I created on a business trip in around 2016. I had gotten some inspiration from this NI forums post talking about using Redis and LabVIEW. It had kind of come on my radar. It had kind of looked at like that's an interesting open source project. I want to learn a little more about that. Started seeing how it worked. Again, made the comment to myself, it can't be that hard, right? And it wasn't. Like I made this on a business trip in the evening on probably 6 or 8 hours of code over a couple of weeks. 6 or 8 hours of development time. I was playing with at the time and, kind of got it built into a VI package because, this is useful. This is really cool. I like this. I like how it works. We should use it in this project. All right, let's get it built into a VI package. So we built it into a VI package. I made 2 or 3 small bug fixes to it over the next 6 months to a year. And as always happens with those internal packages that get basically 0 testing and 0 development time, the use of it skyrocketed, right? It got built into all kinds of stuff that I had no idea it was going to get built into. So that was our dilemma, right? We had this awesome package of stuff, a set of VIs. It was all natural. There was literally no DLLs. It was the way that Redis works. Again, I don't want to get too deep into it, but the way that Redis works, at least in the way that I was using it, it's all basic, simple strings that you're feeding over TCP IP sockets. So this was awesome. I knew I could do this in LabVIEW. I knew when I finished building it, it would be cross-platform. It could run on Linux. It could run on Windows. It could run on RT. It could run it could run on Mac OS as well at the time. It was literally just, we're going to open up a TCP IP socket. We're going to send these string-based commands to this remote server, and we'll get stuff back to it. So we can do things like setting a key value pair. I could say set this key to this value. Separated key and value by a single space or a single white character like a tab. And I have set that key. And it was just a very simple, really very human readable command set. Especially if Redis has got a bazillion things it can do, but its basics are really pretty simple to understand how it works. And so the toolkit itself, again, it didn't take but maybe 5 or 6 hours to kind of build up over a couple of evenings to build up what we needed. And so you can imagine it was pretty easy to use. It was really useful to us and kind of served as a replacement for network shared variables for us. So then came like I said, it skyrocketed, right? The use of it skyrocketed, but we had not really, and we really used it for maybe 5 or 6 or 7 years without a whole lot of changes. But then we had that one project that needed just a little bit more from it. And it needed a little more capabilities and effort. And I've got my colleague up front here is Basil Hall here. He was kind of he's been the leader of that project. And, we started using this and he started finding these issues with it. And he said, I think we're going to need something. We're going to need a better toolkit. And we started talking about replacement. And as he started talking about to the other users that were using the Jacobs Redis toolkit at the time, he started asking, hey, have you guys run into this problem? Have you run into this problem? Have you run into this problem? And he found 3 or 4 or 5 things that kind of stacked up to say, we really need to replace this. But he'd reach out to the other teams that were using it, and they'd say, well, I did run into that one, but not any of these others you mentioned. And then somebody over here had run into problem X, right? And this one had run into problem Y and problem Z. And the project that he was working on really hit all of them at the same time. But the problems that they had found, these other smaller teams, they'd worked around it in different ways, right? And so they'd kept the same ideas, but they just kind of worked around it. And as you started looking at those workarounds, of course, they hadn't talked to me about it. not that I really probably would have done anything at the time. I've been super busy for the last 6 or 7 years. And so, but we really could have looked at maybe doing this earlier. But as we looked at those, as they looked at how they'd replaced it and fixed those issues, it was really in a way that was going to cause performance issues. So his project, which needed better performance, couldn't adopt those workarounds, those bug fixes, because we really needed better performance out of this. And as we based more and more off of it, we really thought to ourselves, we need to make this a stronger piece of our code base. This doesn't need to be that 10-hour little LabVIEW side project that we did that nobody's touched in 2 or 3 years. This needs to be something that we're proud of and can work on and make it easier to work on in the future. And so as we picked up that project and said, okay, we're going to do this replacement, right? We've got some funding set aside. We've decided to do this. We're going to make this happen. We had to develop some goals for as we replace this. We did come up with a name. We decided to call our new toolkit Redis G, because we've learned now over the last couple of years, don't base your toolkit off your company name. That's been painful in a couple of instances for us. So we said, okay, we're going to call this Redis G. This will be a new toolkit. But we had some primary goals for that. One was to, again, because it's been used in a lot of places, like it'd be really nice if we didn't have to recode all of those instances, right? We could, some sort of drop-in replacement for the Jacobs Redis toolkit that would just line up and go, right? May not be as performant, right? We were willing to accept if this drop-in replacement may not have all the bells and whistles and all the capabilities and performance capabilities that a switch to, let's say, pure Redis G would have, but it would not force somebody to go back and recode something. So we could have a tool set, we could have a tool that uses the Jacobs Redis toolkit, we could replace it with Redis G and kind of the Jacobs Redis toolkit shim that we built as part of that, which I'll get to in a little bit. And you wouldn't have to rewrite it. But if you did want to rewrite it and went with Redis G, you would probably get a lot of improvements and capabilities and throughput capabilities there, throughput improvements. So we're searching for that. How do we make a drop-in replacement? And that started to bound how we built this up. We wanted the toolkit to be a lot better tested. As I said, this was built over like a couple of weeks on a business trip in the evening. I tested it, but no, I didn't have a whole cadre of unit tests. I didn't have a whole set of things, throughput testing. I certainly hadn't done that. I would have seen some of the problems that Basil ran into. So we wanted to have a set of unit tests and a plan for how we're going to move this forward and make improvements. We wanted it to be deployable to Windows and NIRT Linux and regular Linux and Mac OS. Those are all platforms that we hit on a fairly regular basis, except for Mac OS. The Windows, NIRT, Linux, and Linux are all platforms that we hit on a regular basis, and we wanted to make sure that this toolkit could run across all of those. And again, as we picked ValKey or LibValKey, we wanted to use that C-based library. We wanted to have as much as possible. We wanted to make the C level to make LibValKey talk to LabVIEW. We want to make that amount of code as small as possible and as thin as possible, so that when we move to a new version of LibValKey in the future, we have very little code that is different, right? That kind of shims it together to make it talk to LabVIEW. We wanted to keep that as small as possible to make that easier to maintain and use and reduce support in the future. Some secondary goals that the original toolkit didn't have is support multiple connections to Redis and a focus on throughput, right? That was really the main reason that Basil's project needed this replaced, is they were hitting the throughput limits of the original toolkit. It just couldn't write and get data out and share data out as quickly as they needed to. One of the benefits that had come in the last 6 or 7 years to Redis was this idea of supporting native data types, like native binary types. The original Redis protocol, what have you, really only supported strings. So, if you wanted to write, you could do something like in LabVIEW, you might do like an flatten and unflattened a string, and you could write that flattened binary data that wasn't human readable to Redis, But most of the way that people used Redis in the real world and the way that we were using it was just writing strings. So if you needed to write a number out to Redis, you literally wrote a string version of that number out, right? And so that made it easily human readable, but certainly not a good way to maintain data integrity all the way through the system. And then as we started working on this, we knew we would need a cybersecurity focus, right? And we knew by pulling in something like LibValKey, which already has a huge open source following and a huge open source backing, we knew that basing our library on that rather than trying to write all of that, let's say that Redis interface code ourselves, we would have a leg up for cybersecurity reasons, right? So LibValKey, for instance, already has built-in SSL encryption, like end-to-end encryption that you can do, TLS connections back and forth. Redis itself has the ability to do role-based authentication and control, and which LibValKey supports. And then we'll talk about a couple other things as well. Let's see. So again, I've kind of mentioned it already. I've got a link to it here on this slide, which the slides will be published as part of the conference information. But link here to LibValKey, the library that we chose. Right, it is open source. I've mentioned it's written primarily in C. It can be compiled with CMake or with Make. It's got a BSD3 license, so it makes it very easy for us to incorporate it within a commercial application and use it. So that BSD3 license is a little 3-paragraph license that's pretty easy to read and understand, even if you're not a lawyer. It does support Windows, it supports Mac, it supports Linux, right? It's already got make files and the capability to essentially be compiled. It is what I call currently supported or currently very active library on GitHub. It's got a lot of contributors. They're making releases, whether they be bug fix releases or major releases. They've got a plan. They're continuing to make changes. It's supported by big companies and small. Excuse me. And then most importantly for us is it had the RESP-3 support, which is Redis's serialization protocol. There's a couple of versions of those. RESP-3 is essentially the support for RESP-3. Makes things like ValKey and Redis, and there's another one called Dragonfly DB. It makes them all compatible, right? So this standardization of how data is stored in memory and how it's transmitted back and forth, this serialization protocol, means that, as I've talked about, I've spoken about Redis. Redis is kind of the Kleenex of this. Redis itself is its own open source project that, or at least was at one point open source and now is a little more closed source. LibValKey was split off from that. Dragonfly DB was split off from that. Microsoft has got a version that is open source that is a Redis clone, again, like the Kleenex of this protocol, this in-memory database setup. But as long as they support this RESP-3 protocol, they're all interchangeable with each other. So if I try out LibValKey and it works great for me and I want to try out something else, I can just put it on a server and get it running. And my code that talks to Redis, like this library that we're talking about that talks to Redis, will not know the difference between the servers. Maybe one of them will be drastically faster than the other. That's, in fact, one of the reasons ValKey exists is because it's not only is an open source clone of Redis, it also has multi-threaded support. Redis is famously single core, single threaded. And so ValKey has got some support for multi-threaded applications that make it give you some benefits in other places and benefits, and there's pros and cons to it. And Dragonfly DB is, again, another one that is a Redis clone that is multi-threaded, and their benchmarks show it being 10 times faster than Redis, for instance. So it gives you some capability to really try out these other libraries. But LibValKey is the ValKey version, the client, right? So this is how I'm going to go talk to a Redis server. Again, it's an open source library written in C. One of the other benefits, secondary benefits that we saw to that, again, I talked about the cybersecurity benefits, the TLS support that's built into it. So again, I can use TLS, I can turn on TLS connections to a Redis server, and now my data being transmitted from point A to point B is encrypted. And I don't have to do anything to encrypt it. I can just pass it off to the LibValKey client, DLL that we use, or shared object, and it encrypts it. And then on the other side, it's unencrypted where needed within the Redis server itself. And then another one that really excited us was RDMA support. And again, I know the first time we'd kind of heard about this is maybe 18 months ago to 2 years ago, but we saw a presentation last year from Genuine with RDMA, talking about RDMA support. And RDMA support there's also some nice YouTube videos here that have been put out in the last few months where a lot of YouTubers got like 3 or 4 Mac Studios with lots of RAM in them, and they connect them over Thunderbolt. And because Apple had introduced this networking over Thunderbolt, had introduced this RDMA support within that Thunderbolt stack, and essentially it allows over standard networking gear, not just Thunderbolt, but just standard Ethernet. It allows for very quick memory to memory and device to device transfers, much like reflective memory is a kind of the older technology that did this for controls industries and for our industry as well. But RDMA promises response times very similar to reflective memory, but just using standard Ethernet and standard networking protocols, and essentially allows those networking cards to share data with each other and then get it very quickly into the user application space for making decisions on. So high throughput, low CPU usage data exchanges. So another side of this, again, we've talked about Redis G in a little bit, but one of the other things that we really wanted to do in the last year or so as we've worked on this is how do we use more AI? And how would AI help us make this quicker? That was part of what we looked at for this particular application as we started using it. One of the things that I'd say our company has done a good job of over the last year is hiring more people, right? But that means we've hired 6 or 7 people in 6 or 7 months. And part of the downside of that is those 6 or 7 people might be straight out of college, or they might have 2 or 3 years of experience. Almost none of them had LabVIEW experience. Almost none of them had even data acquisition experience, right, and controls experience. So we've been able to get some bodies in as software engineers, but we've had to do a lot of training and consider them still kind of junior programmers and junior level programmers in terms of experience. And so what that's done is that has put a strain on our senior developers like myself and like Basil we've got bodies to get things done, but we don't have bodies with experience. So how do we help them and how do we help them be efficient? Because again, we're always working off of a budget. How do we help them be efficient? How do we help them get enough to work themselves without asking us questions every 20 seconds, right? How do we help a junior engineer get efficient and understand what he or she is working on? So as we went through the planning process, we gathered the requirements. I talked about some already, but we made some plans. We did some evaluations. Some of the things that Basil's team did really well was look at options for us, whether that be other Redis clients. We looked at different ways we could do this. We looked at what we wanted our library to be able to support. We looked at some of the capabilities. Again, I talked about, the RDMA capabilities and TLS support. Those were things that we wanted to make sure we had because we knew it was going to be, if it wasn't a requirement right now, it was going to be a requirement very soon. So we wanted to look ahead and make sure we had those capabilities. And then as we looked at, we had AI coming on the scene and available to us with things like Copilot and ChatGPT. How could we use AI to help us make this code base stronger and better? How could we use it to rapid prototype? And so that's some of what Basil and his team did, was to come up with and start asking Copilot and prompting Copilot to help us design like prototypes of a LibValKey client that had this, as we documented kind of how we were going to make it talk to LabVIEW and the DLL endpoints that we would want to have to make it talk to LabVIEW. And we would say, hey, Copilot, help us, here's the 5 endpoints we want to have within our DLL. Help us write a shim that takes these calls in LibValKey and gives them to us at this endpoint. And really, as part of that process, we we got to learn a lot about how you do that with AI, whether it be prompt engineering. I don't really care what you want to call it, but things like prompt engineering is what kind of makes sense to me. But how do we engineer our prompts? How do we very quickly get 5 different options out of AI? Ask it to go tackle the problem this way, and go tackle the problem this way, and this way, and this way. And one of the things that we found was doing that gave us 5 or 6 different options, none of which we could use right off the bat, right? But they all had different ways. The AI had kind of dreamed up 5 or 6 different ways based on our prompts of how to solve this problem. And we could look at problem solution A and say, most of that's junk, but there's a few gems in there. There's a few interesting things. And we'd look over here and we'd look over here, and then we could start to form and say, hey, AI, how did you generate, or why did you choose to do it this way? What part of my prompt led you to generate the code this way? Or we'd ask it questions about the code it generated so that we could then kind of become this master prompt and say, 3 or 4 paragraphs of, okay, here's the thing I want you to go generate for me. We got to compare things like Copilot along with open source models that we could run on our own hardware, right? So that's one of the things that this project didn't pay for, but did help prompt, is getting resources, internal resources for our company that we could have put our hands on and literally run some of these open source models on. As a government contractor, which again, I didn't necessarily say that at the beginning, but from my time on the keynote stage, we're a government contractor. We do a lot of commercial work as well, but we do work for governments around the world. And when you do that, and especially even with commercial work, right, you have to be careful what you feed into an AI. I can't feed a customer's data into the AI. In some cases, I can't feed the code, at least some of the code, I can't feed into an AI for it to evaluate and work with. But in this particular case, where we're taking an open source library, which is publicly available, it was really easy for us to say, this is an opportunity for us to use AI and use public AI and compare things like ChatGPT and Copilot to some of our own internal models. And even, like I said, come together and blend all that together into a final piece of work. The AI helped us with a lot of rapid prototyping and documentation, building unit tests. In fact, one of the things that Basil and I talked about earlier this week is probably something like 60 to 70% of the code that's in our shim level is what we call input validation. So it's that kind of code that we probably would not have written. Did you send me a null pointer? There's 3 things in here you're sending me. One of them is a pointer. Did you send me a null pointer? How do I check that? If you did send me a null pointer, how do I know back in the LabVIEW side, like from the DLL, recognize this is a null pointer? How do I send that back to the LabVIEW side to say, hey, this first argument was bad. This pointer that you sent me is bad. The array that you sent me is supposed to have 5 elements. It's supposed to match the size of this other input over here. Do they actually match? Are they supposed to match? That kind of code we would not have written ourselves, and because it's kind of tedious. It's difficult. Thinking of all the conditions you could run into, we would not have written that ourselves, and we would have had a less robust library out of that. And so we had the AI really help us with that as well. Especially, we kind of almost stumbled upon it. We asked it to modify a function, and it did, and it threw a couple of input validation pieces in there. We asked, what is that? What is it doing that? Why are you doing that? And we said, yeah, we really like that. Is there more you would want to add? Yes, there is. I actually would want to add 5 or 6 more. We did a little more research onto it and found a prompt that we could feed the AI that's like, I want you to imagine you're the C programmer who hates memory leaks more than life itself, right? And all I want you to do is try to find memory leaks in my C code. So we could prompt engineer our way into look at our source code, find the memory leaks in here, find the places where you would want to put input validation. Find those places, show me that code, maybe modify it yourself, AI code, or show me what I should put in here to make it work, right? So that was some of what we did. Again, the unit testing that we had, the AI help us with as well, provides us a much more robust product. We would not have written as much unit testing as we have if we had to write it ourselves. Even the logo, yes. Yes, we even asked for help from ChatGPT, I think, or one of the other, or maybe Copilot as well. But yeah, it makes some pretty cool logos. We're engineers. We are not artistes, right? But we had it help us make logos as well. So kind of the results of that planning and our process was we were able to make, I think it's been eight releases in the last couple of months. We have got a whole suite of Karaya unit tests. We've got a whole set of throughput testing that we run on every release. We also use ASCII doc. Again, this is something I'll talk about more at GDevCon, but if you haven't run across ASCII doc as a documentation system, it's very similar to Markdown, which is pretty popular now, especially something you feed to AIs. But ASCII doc is a little more robust and a little more rules-based and maybe a little more oriented around printing, something that you might eventually print. But it's a nice text-based documentation tool that, again, looks like source code when it's all written up. And so it's very just plain text. You run it through a compiling process and you get a PDF out on the other end, or an HTML page, or an ebook, or whatever you want to have on the other end. But essentially, your documentation becomes source code that you can check in and keep in Git or GitHub. We also use the tool, the LabVIEW toolkit Antidoc, which uses ASCII doc and produces ASCII doc to generate its LabVIEW documentation. So we were able to use that as well to help document our library. And again, a lot of those tools and all of those capabilities were really handy for us as we used that and released this toolkit with us. Okay, a few things we learned, and then we'll get to questions, right? For us, the AI prompts I've mentioned, I've kind of touched on it already. We needed to become prompt engineers and really think about it. And one of the biggest things that we really started doing is we have in our repo the prompts, right? We kept our prompts in there and said, this is the prompt I used to get this, and this is the prompt I used to get that, and here's how we might build a new prompt in the future, right, to help us with the AI to get particular outputs. We really did find it helps junior engineers, and it does help senior engineers as well, because again, those senior engineers and those junior engineers can prompt the AI and say, well, why did you do this? Like one of the things that I know Basil found and the junior engineers found, there was a compiler macro that we'd never seen before. Why is that? Why are we doing that? I don't know what that does. The junior engineer's first answer was, well, the AI put it in there. I don't know what it does either. It's like, not a good answer. You have to understand how this works and why it's doing this. So, I mean, again, Google it, ask the AI. Just because the AI put it there is not the right answer. Go understand what it's doing. Let's dig into it. I've never seen that one either. I want to know what it's doing. So again, the third bullet there, code still must be understood, right? The work that we do and the type of work that we do and the situations we get ourselves into and the kinds of projects we take. I've worked in the middle of Death Valley for 2 weeks at a time with no internet access. I'm just lucky my cell phone didn't melt, right, in July in Death Valley. It's really hot. There's no internet access. There's no AI access there. I've got to understand what the AI generated for me in those kinds of situations. I can't depend on being able to reach back. I can depend on reaching back to friends and asking for help in the office, but just barely. I barely got a phone line in some places, right? So the kind of work that we do and the kind of things that we're working on, you still have to understand what the code does. We have found it really helpful, though, for writing unit tests and for helping us with code reviews, and especially with our junior engineers saying, I know maybe you're not super happy writing unit tests, but why don't you have the AI help you and see if you can get several of these cranked out. So the release process for us, this was a little bit new, that we were able to automate a lot of things and really learned to automate even more of our release process. Because that way you get the same thing every time, right? A CI/CD process. I know I've talked about that a few times on stage this week. It's been talked about with others. That CI/CD process and a CI/CD automated build process really is important for us as we go forward. For us as a platform, for us as a software engineering as a field. right? As we get asked more and more about cybersecurity and releases and software bill of materials and things like that, knowing what's in there and how your automated build process works is super important. For us, we also talked about, I briefly talked about anyway, cross-platform testing. Like, how are we going to test this, not just on Windows? How do we test it on NI Linux? How do we test it on regular Linux? How do we test it and know that, how do we do that much testing on all those platforms? Because we knew we would have it running at least on Windows and NIRT, and Linux was a very strong possibility as well. So how do we make sure that the library works the same way on all three platforms and that it provides the same information and has the same throughput, or at least similar throughput numbers on all three? So again, automation where possible, either with unit tests or with what I call user testing or acceptance testing, where you've got some source code you're going to run that exercises your library and returns some results. Maybe it returns it as a unit test. Maybe it's just something that's manually run, but a set of unit tests and documented testing, manual testing or automated testings where possible. And then one of the other things we did, again, by using LibValKey, there's a bunch of unit tests built into LibValKey as well, right? So using those unit tests and understanding those unit tests and replicating them maybe where necessary to understand this is what this unit test is doing with LibValKey. Since we've got this small C or C++ layer on top of it, we need to probably replicate some of what that unit test does so that we ensure that we're passing all the right values down to LibValKey and all the right conditions come out of it. And we deal with the errors that might occur within that shared library so that we know we're passing those errors on up the chain to the LabVIEW user, the LabVIEW programmer. For unit testing, a couple of things that we learned is like, you're not going to write them all at once. Again, if you haven't done this much, it's a lot of extra code. It can be anyway. It can be a lot of extra code. The best way to get started is to write a few, and then write a few more, and then write a few more, right? You don't have to write them all at once. Getting some coverage, having some understanding of how much that unit test information covers your source code base and how much is tested is really important. And again, I mentioned it already, but AI can help you there, right? Have it suggest unit tests, have it help you write unit tests. You still have to understand them and code review them, let's say, but it can help take care of some of the tedious work that goes along with that. And then before I closed, I want to talk about there's a couple other. There's another company, and other companies have done this before. We're certainly not the first. I just wanted to talk about our story. But if you're interested, there's a couple other toolkits that are out there, and GitHub repositories, I think, is what I've got linked here. But this one, this JKI request, that is JKI's wrap of the REST. The Rust HTTP request library. So the Rust HTTP request library is really popular, very robust, got a lot of capabilities. JKI needed that and essentially went to the point where they built a wrapper for it and a way to integrate that into LabVIEW. I'm not 100% sure they've released it as a toolkit for others to use just yet. I think I spoke to them and they do use it internally, but haven't necessarily released it as a toolkit for others to use. But again, it's a GitHub repo. It's out there. The link is in the presentation here, and you can get more information about it and see how you could use it. And then another one that they use and they have developed, and I do believe they have released, is called their TOML editing. Again, TOML is another kind of configuration file, much like YAML or INI files or JSON files or XML files. TOML is just another one of those. It's definitely got some advantages over other types of configuration storage formats, but there's not a native like LabVIEW toolkit to read it in and write it out. And so there was one for Rust, and so I think they went through the process of kind of wrapping Rust's reading and writing of TOML files and made it accessible to LabVIEW. And again, some of the same ideas. They built a small layer of code that they maintain that essentially matches calls that they've got in LabVIEW and matches those up with calls in those either like in the Rust libraries. and passes data back and forth. And they try to do the same thing, right? They try to keep that layer of either C or Rust code that they've got that allows that communication path, try to keep that to a minimum. So they're just using the plain vanilla library as much as possible. And they just got this kind of shim layer to pass data back and forth to make it easier to talk to with LabVIEW. All right. So down to our last 15 minutes. Any questions or comments from the audience? All right. Well, one more time, I'll bring up the GDevCon 2026 event. QR code's up there if you're interested in going, or if you're curious about what a GDevCon is like, please come find me afterwards. I'll be happy to sing its praises. I've enjoyed going several times. But these are GDevCons around the world that you can attend, and that QR code will help you figure out more information about which one might work for you. Thank you all very much for attending today, and have a safe trip home. I'm going to be leaving for the airport soon myself. So everybody have a safe trip home. I hope you've had a really good NI Connect. I know I have, and ready to get back into work next week and take care of problems, right? All right. Thank you very much, everybody.